Hey, Dr. Lincoln. Hope you're doing well. I thought I'd just make a video for you demonstrating some of the stuff I've been doing, just to update you for the week. So first off, I just want to show you the activity for the air sensor. This one kind of worked pretty decently. I saw like a pretty, like you can see a pretty linear decrease in the numbers, at least when you're looking at the graph. And then you can pretty clearly see like once you stick the sensor in there, it immediately lights up to red, and then it kind of, as the alcohol from the hand sanitizer evaporates, it slowly, like the lights slowly start going down. Um, so this might be actually a pretty good activity. Um, I'm gonna just go ahead and share my screen so that you can see the graph from the Arduino stuff. Let me pull this up. Okay. And then I'm just going to re-upload the code just to refresh it. Okay. And then let me pull this up. And then, okay, here we go. I'm trying to make this bigger. Hopefully that's fine. Okay, cool. Okay, so down here are you can see the numbers just displayed. And then here's the graph. So what I've been doing for this one is you take a little bit of hand sanitizer. You want like the tiniest amount. I found that it's really easy to go overboard with the hand sanitizer. Because if you put too much in there, it just takes a really long time for it to evaporate. Even with just like what I'm going to do here. So I'll just do basically like two swipes at the bottom. So it's just like a really thin layer. And then I'll go ahead and stick the sensor in here. And then as you can see, the numbers immediately kind of jump up. And then it's red. And then once it gets going to actually evaporating, you'll see like it start kind of having like a pretty linear decrease in the numbers. But it does take, I timed it before, and I think it took like a total of maybe like 3 to 4 minutes for it to fully go back down to green. Um, so I don't know how like the timing is for this activity, but I'll let you just kind of like think about it too and just let you observe what happens for this one. But like you can kind of see from the graph here that it's just the numbers kind of go down very linearly. So I'll just give it a second and let it kind of go down. And then I guess I'll just, oh wait, okay. Okay, yeah, the red one just turned off. Cool. Um, so then the other ones should turn off soonish. The red one kind of takes a while for that one to turn off first, and then the other ones go down a little quicker. I'm not really entirely sure how we might like make a story from this though. This is like kind of oh the light just went down. Because it's evaporating gas, and so maybe but I don't know. Maybe we can just talk about emissions or something. I'm not sure. It's just I'm trying to like think of how the activity will actually play out instead of it just being them like watching it. But you can kind of clearly see the air quality difference and it kind of improves as time goes on. So that's a good thing, I feel like. But yeah, now we're back down to green. So yeah, it took a few minutes, but I don't know if that's a bad time frame or if that's pretty good for an activity to take a few minutes. But I think it worked decently. Like you get some decent results for it, and you can kind of clearly see that the air quality improves over time as it evaporates. So I think that might be a good thing to touch on for sure. And then, okay, I'm gonna go ahead and just unplug this one and move on to the next. Okay. Let me do this one. So this one's the power meter. Just plug that in. Okay, let me pull up the other code for this one and upload it. Uh, yeah, okay, cool. Um, okay, let me upload this. Okay, cool. So you can kind of see the numbers down here getting displayed. You got so it's basically measuring the voltage, the current, and then calculating power. The way I'm doing this is um with an Arduino, you can, as long as it's in between 0 and 5 volts, you can kind of just directly plug a pin in. So like right now I just have one of the analog inputs for the Arduino just reading directly from where like the positive lead is on the breadboard right here. Um, and it's just taking the direct voltage reading from pretty much essentially the power supply. I have that hooked up to it right now. Um, but for the current, what I'm doing is I have these two, I don't know if you can, it's probably hard to see. I'll try to raise it up a bit, but so 1 second. Okay. So I have two resistors here. They're acting as like a voltage divider because earlier, whenever I was testing this, I wanted to make sure that the windmills we just ordered would work for this. So I think those ones, I can't remember exactly, but it was either in between 0 and 6 volts or 0 and 12 volts. But since Arduinos can't read above 5 volts, you have to use kind of like a voltage divider. So I was kind of using the middle in between these two resistors to take the reading from there because that was always below 5 volts. Because you can just use certain values of resistors to kind of divide the voltage up or like break it up. But anyway, now that I have these two resistors here, the way I'm measuring current is I'm just taking the voltage drop across them and then dividing it by the resistance. So just like the standard Ohm's law equation, that's how I'm calculating current. I'm not sure if it's, exactly the right thing. And then these resistors are actually really high. So the current is super low. It's in like micros or like microamps, which is, I mean, that's fine. We would just have to like be careful of the scale for the power meter. Um, because like right now, that you're only producing like, I think the max amount that I can do with 5 volts with this setup is like 300 microwatts, which, that's pretty small. So we can change the resistor values to, get more power if we want to, but I don't know if it really matters. We just need to kind of display a number and then a power meter. So far, I don't have the timing thing set up yet, but I do have the power bar working. So I'll try to show the power supply and the power bar at the same time. And then I'll let you read the numbers too. So it's decently accurate whenever you're doing just 5 volts. Like as you can see, it's 0.68 volts, and then it's reading like 0.69, 0.68 right there. So it's pretty close. And then as you increase it, the bar will go up slowly with like the increasing voltage. So that's kind of like the power meter right there, up to the maximum of like 5 volts. It should fill the bar all the way up. As you can, well, there's one more bar. Oh no, okay. Um, yeah, so you can see it kind of went up and then pull it back down, it'll go down. I can change the delay in here so it doesn't, sometimes it's a little like, it's a little bit delayed. So I might change that to make it more responsive. But I think this one would work pretty well. I just want to get those windmills and then kind of plug those in to see if it will do the same thing as the power supply does. And I'm pretty sure we won't have to be too concerned with going above 5 volts because I don't think those windmills will really produce more than that. Same thing with the solar panels, because most of the ones I saw were like 3 volts. I think the only thing we need to be careful with this one is doing negative voltages. I found that out the hard way with the other windmill thing that I had showed you earlier in the lab. I had plugged that directly into one of those pins and I immediately spun it the wrong way and then pulled a negative voltage out of the pin, and it kind of messed it up, or messed up one of the pins that I did that on. So I'll have to implement some like protections for the circuit so it doesn't pull negative voltages or anything like that. But yeah, I kind of like this one. I think it'll work well. I just want to test it with the windmill, and then I'll also put in the timer thing to see if we can get like some kind of a game going on where they have to like produce the most power in a certain time once like you hit a button. So I'm going to implement that in the future. But yeah, I'm going to go ahead and go to the next one. Okay. This one is the turbidity sensor. So let me pull that code up. Okay. Cool. Let me upload this. Okay. So I got this one working to display like the percentage turbidity. So basically 0% is clear water, and then 100% is like an opaque, is like opaque. I was having some troubles with this activity. I'm not entirely convinced with this one yet. I'm like more confident with the other two, the first two that I showed you. I feel like those are kind of going somewhere. This one, I don't know. So I'll just go over the problems first, I guess. So the main problem is that the sensor that we got here is not submergible, like it's not waterproof. So you can't submerge it past like where that black line is, because that's like, this is just like a plastic cap that's kind of clamped onto it. It's not sealed or anything. So if you dunked this whole thing in the water, it would just break. And I think if we used this particular sensor, then we would have to waterproof it somehow, because I wouldn't really trust the kids to not just kind of dunk it in the water. And then, yeah, so I'll go ahead and demonstrate the activity real quick. So I'll get that set up. Oh my gosh. Okay. So I have some food coloring and then just a glass of water. Right now, there's nothing in it. It's just clear. So I'll go ahead and take a reading of this for you. As you can see, it's kind of down to like 2.25% right there, which is kind of pretty consistent as what it's been every single time. At least for my water. Maybe if you have super like distilled, it might actually go down to 0, but mine's around like 1.9, 2.25 usually. Um, but the unfortunate thing is that at least with food coloring, I have tried it with some other things, but I'll just go ahead and show you what happens with this. So put a few drops in here and then mix it up. Like I would think that it would have changed the value like a readable amount, but really, so I'll do another reading. You see, it's kind of like the same. Now it's even lower. Now it's 1.9, which seems kind of counterintuitive to me. And I'm not sure if it's just maybe food coloring doesn't like reflect or like deflect a lot like light much. I don't know. So I'll just put a whole bunch of food coloring to see if it improves it. Because at least whenever I was doing this, it seemed like no matter what, it didn't really make too much of a difference. Yeah, now it's at like 2.13. So I'm not sure if it's something with how I have the code written and it's just not really working too well. But I feel decently confident with the code. Maybe food coloring is just not the right direction. So I did also try it with just dumping salt in the cup and mixing the salt up, and that worked okay. Because it made the water cloudy, and you could pretty easily tell that the percentage number started growing up as you added more salt, and it was pretty measurable with this sensor, but the salt eventually dissolves and then it just kind of turns into clear water again. So I don't think that would be a good option either, because it wouldn't, you wouldn't really be able to keep a consistent like cloudiness level, I guess, because it would just clear up. I did also try dirt too. That one was also not the best option either, because the dirt kind of what happens with if you use dirt is it kind of, if you can see that like, oh, here we go. So like how it's kind of split in the middle there, the dirt gets trapped in between that split right there and just gets stuck. And once the dirt goes in there, then the sensor doesn't really work anymore since there's stuff stuck in there and it just gives you a reading of like 100%. Even though that's not really necessarily the case. So I think maybe the code needs to be worked on too, but I think I'd like we need to find something else to put in the water to make it cloudy. That would be like a little bit more consistent. So I know that these sensors are used for like, I think they're used for washing machines really to like detect if the rinsing cycle is done. So I think they're really meant to kind of see how much soap is in the water. I might try that. I might try like some soap. Maybe I can find like a darker colored soap or something that would be pretty visual and try that. But right now I'm kind of uncertain how to move forward with the turbidity one. Maybe it might be better to go into like a TDS, like the total dissolved solids instead. And maybe we could try one of those sensors and hopefully they'll be like waterproof already. And then we can just use salt and test the salt because that might be a little bit easier to do than using the turbidity one. But I'll explore some more options to see how that works out. But yeah, I just wanted to update you on that. So future work that I'm going to continue on doing for the rest of the week is the sound sensor. The code's already updated, but I haven't actually tested it yet with the new sensor. I'm going to test that, work on the turbidity one to try to find something else that works better for the demonstration, and then add the timer to the power meter to see how that works. And hopefully we'll get the CO2 sensor in the windmills in the mail soon so I can kind of start testing those out. Because I already have the code done for the CO2 sensor as well. But yeah, I'll just kind of continue on that stuff. But yeah, hope you get better soon. But yeah, see ya.